Hey guys! So in this video, we'll take a look at some sample problems about the topic we discussed on the previous video. So for the first example, we have here, pin P at the end of the telescoping rod slides along the fixed parabolic path y squared equal to 40x, where x and y are measured in millimeters. Now the y-coordinate of P varies with time t, which is measured in seconds, according to y equal to 40 squared minus 60 millimeters. Now when y is equal to 30 millimeter, compute the velocity and acceleration of pin P. So if you can imagine, as this rod rotates, the position of point P, itong nasa dulo niya, also changes. So it will move along this path. So let's say that this is the initial position of P. This will be the x and y coordinate of P. Now after some time, P will move. Okay, so let's say it is now in this position. Okay, so ibig sabihin, yung x and y coordinate niya ngayon, magbabago rin. Okay, so from the problem, the y coordinate of P varies with time t according to y equal to 40 squared minus 60. Ibig sabihin, alam natin yung y coordinate ng point P at any time t. Okay? So, how about yung x? Paano natin malalaman kung nasan yung x natin? Kayo, nasan na yung x niya? Charla. Okay, so what we can do is substitute the equation of our y coordinate to the equation of the path. Okay, so isa-substitute natin yung y coordinate natin in terms of time t dito sa parabolic path equation natin. So, y squared equal to 40x. So, that will be 40 squared minus 60 squared equal to 40x. So, if we simplify this for a bit, we will end up with this equation. X equal to 0.4t to the fourth minus 1.2 t cubed plus 0.9 t squared. So, ngayon, meron tayong equation for our x coordinate in terms of time t. So, these equations will be the components of our position vector. So, ngayon, sa velocity vector natin, again, recall that our velocity is just equal to the first derivative of our position. So, yung y component ng velocity natin, that will be the first derivative of the y component ng position vector natin with respect to time. Okay, so derivative nito, that will be equal to 8t minus 6. And then similarly, for the x component of our velocity, that will be the first derivative of the x component of our position vector with respect to time. So, first derivative nito, so that will be equal to 1.6 t cubed minus 3.6 t squared plus 1.8. Okay, so again, the problem asks for the velocity at y equal to 30 millimeters. Okay, so mapapansin nyo, yung velocity vectors natin, yung components ng velocity vectors natin is in terms of t. Okay? So, hindi natin pwedeng i-substitute kaagad yung y equal to 30 millimeters doon kasi walang variable y. Kailangan natin hanapin muna yung time. Okay? So, the time that it will take for the pin P to reach y equal to 30 millimeters. So, yung gagawin natin, we will take the y component of our position vector. So, y equal to 4t squared minus 60. And then, isa-set lang natin yung y coordinate natin equal to 30 millimeters. So, from this equation, so since quadratic siya, meron tayong dalawang t or time na makukuha. Okay? So, kukunin lang natin yung positive value. So, that will be equal to 3.589 seconds. Ibig sabihin, it will take pin P 3.589 seconds to reach y equal to 30 millimeters. So, meron tayo ngayong time. Gagawin lang natin is again, nahanap yung velocity vector. So, isa-substitute lang natin doon. So, for the x component of our velocity, time, we will just put 3.589 seconds. So we will have 34.06 millimeters per second for the x component of our velocity. Now for the y component, again, we'll just use 3.589 seconds for our time. So that will be equal to 22.71 millimeters per second. Right? Therefore, our velocity vector now in vector notation will be equal to 34.06 I plus 22.71 J millimeters per second. Okay, so how do we visualize this velocity? Ano bang itsura nito? So again, recall that our unit vectors I and J indicates the direction of our vector. Therefore, our velocity vector is 34.06 millimeters per second along the x direction or along the I direction, and then it is 22.71 millimeters per second along the y or j direction. So the magnitude of our velocity vector will be equal to this. So para makuha natin yung magnitude, yung gagawin nyo lang parang Pythagorean theorem lang. Okay? Kukunin nyo lang itong diagonal na to. So that will be equal to 40.94 millimeters per second. Again, yung gagawin nyo lang dyan, bale square root of 34.06 squared plus 22.71 squared. Okay, so that should give you 40.94 millimeters per second. And then, for the direction, let's take this angle. So that will be with respect to the x-axis. So let's say that is angle beta. So this will be equal to the arc tangent of 22.71 over 34.06. So our angle beta will be equal to 33.69 degrees. Okay? Therefore, our velocity vector in magnitude angle notation will be equal to 40.94 millimeters per second, angle 33.69 degrees. Okay? So again, yung angle natin dito is with respect to the positive x-axis. Kahit saan dito sa dalawang notation, tama. Okay? So basically, equal lang naman yung dalawang yan. So both of them are correct answers. Okay, so next, hanapin naman natin yung acceleration vector. So again, acceleration, that is just the derivative of our velocity vector. So madali lang to. Bale yung y component ng acceleration natin will be equal to the first derivative of the y component of our velocity vector with respect to time. Yung derivative nito with respect to t, that will be equal to 8. And then yung x component naman ng acceleration natin, 4.8 t squared minus 7.2 t plus 1.8. Okay, so again, the problem asks for the acceleration vector when y is equal to 30 millimeters. Since yung acceleration natin, again, is in terms of time t, so yung gagamitin natin, or yung ilalagay natin na time will be 3.589 seconds ulit. Okay? So for the x component of our acceleration, again, ilalagay lang natin na time is yung 3.589. So this will be equal to 37.79 millimeters per second squared. And then for the y component of our acceleration, 8 lang naman yun. So that will be 8 millimeters per second squared. Okay? In vector notation, that will be equal to 37.79 I plus 8j millimeters per second squared. So same dun sa velocity vector natin, ma-visualize din natin yung acceleration vector natin na parang ganito. Again, 37.79 millimeters per second squared yung x component niya, and then 8 millimeters per second squared naman yung y component niya. Therefore, yung magnitude ng acceleration natin to be along this direction, and that will be equal to 38.62 millimeters per second squared. Okay, ngayon yung direction niya naman, let's say from the positive x-axis, let's say that angle is angle alpha. So this will be equal to the arc tangent of 8 over 37.79, which is equal to 11.95 degrees. So therefore, in magnitude angle notation, yung acceleration natin will be equal to 38.62 millimeters per second squared, angle 11.95 degrees. So, same dun sa velocity vector natin kanina, both of these notations are correct. Okay, so for the next example, we have a projectile fired at point O follows a parabolic trajectory given in parametric form by x equal to 66t and then y equal to 86t minus 4.91 t squared, where x and y are measured in meters and t in seconds. Determine the maximum height h and the range L. Okay, so medyo madali lang siya kasi yung position vector natin, let's say that is R. So yung components niya, given na. Yung parametric form na binigay sa taas. So yung position vector R natin, that will be equal to 66t I plus 86t minus 4.91 t squared j. Okay, so for the velocity vector, alam niyo na kung anong gagawin. Okay, so diretsoy na lang natin. Our velocity vector v, that will be equal to 66i plus 86 minus 9.82 t j. Again, kung ginawa lang natin, we just took the first derivative of our position vector with respect to time. So we need to determine the maximum height that our projectile will reach. So if we analyze the motion of our projectile, it will reach its maximum height when it is not moving vertically. Okay, so just before it starts to go down. So yung y component ng velocity natin, that will be equal to 0 at the maximum height of our projectile. Using the y component of our velocity vector, makukuha natin yung time t when our projectile reaches its maximum height. So the y component of our velocity, again, that is 86 minus 9.82 t. I will just set our vy equal to 0. So solving for t, that will be equal to 8.758 seconds. So again, yung maximum height natin, since that is along the y direction, ang gagawin natin is yung y component naman ng position vector natin, yung gagamitin natin to find the maximum height h. So if we substitute this time into the y component of our position vector, we should get the maximum height of our projectile. So again, setting t equal to 8.758 seconds, we will obtain the value of our maximum height h equal to 376.58 meters. Okay, so next, hanapin naman natin yung maximum range L. So as shown in the figure, when the projectile reaches the maximum range of its flight, so that is L distance from the origin, so mapapansin nyo, yung projectile natin, it will be 120 meters below the origin. So if we substitute this value into the y component of our position vector, makukuha natin yung time that it will take for our projectile to reach its maximum range. Okay? Again, y equal to 86t minus 4.91 t squared. So isa-substitute lang natin negative 120. Okay? So negative yung ilalagay natin kasi it is below our origin. So if we take values upward as positive, therefore yung pababa, that will be negative. Okay, so negative 120 yung y natin. And then if we solve for t, again, since this is a quadratic equation, dalawang values yung makukuha mo. So kunin lang natin yung positive value. So that will be equal to 18.814 seconds. Ibig sabihin, it will take 18.814 seconds for our projectile to reach its maximum range. So to solve for the actual distance L, ang gagamitin naman natin ngayon is yung x component ng position vector natin. Kasi yung L or yung maximum range natin is along the horizontal x direction. So x, that will be equal to 60/60. So again, substitute lang natin yung time na 18.814. We will get the value of our maximum range equal to 1,241.72 meters. Okay, that's it. Thank you guys. See you on the next video.